Hi folks, okay, we're here for Tuesday's videos. It's probably going to be in two of them. It's going to be a review of differential equations, which I've been assured is pretty much going to be some type of question on the AP, and slope fields. Remember, the whole key to solving differential equations is separate, integrate, and solve. You separate the variables based on D's and the other letters. You then integrate that problem, and then you solve it. So what I'm going to do a couple things in this video. First, I'm going to review the basic piece kitty and the piece kitten problems. All of this is in your AP review packet from me on pages 30 through 33. We're then going to do a couple of basic solves. And then we are going to look at an AP problem that has both in it. It's going to be the 2018 AP, number 6. And I'm also going to show you how to do it in the calc, because I don't know how much they're going to ask you to do, because you can always enter these into the calculator. I'm going to assume that they don't think you can, but we'll break these 1, 2, 3, 4 things down in the two videos I'm going to send out today. Okay. First of all, differential equation is just an equation that relates rates and quantities. Rates and quantities, that's it. The most common type of differential equation is one that says the rate of change of population is directly proportional to the population itself. That's the most standard type. Another type you might see is that the rate of change of population is inversely proportional to the population itself. Those are other types that you might, oh, I wrote that wrong. Who wrote that? Inversely proportional. You might even see one, all this is in your packet if you want to take a look at it. The rate of change of population is inversely proportional to the square of population. Excuse me, the solutions, the way you solve all of these equations is exactly the same. You're going to separate, integrate, and solve. So I'm going to do step 1 first, which is separate. So the problem is easiest when things are kind of opposite each other. On this second one here, I can just cross multiply, and I get P dP equals K dt. You may ask, where does the K go? The K is a constant, doesn't matter which side it goes on. We usually put it on the right side of the problem. Let's look at the next one over here. dP dt, if I do this, I get P squared dP equals K dt. I've done that. Then there's other ones where you can't actually get the thing by itself by cross multiplying. So if I was to take this problem, I would cross multiply away anyway. I'd get dP equals Kp dt. I'm going to do another one like this, so I have 3 now. No, too many at a time. The problem now is I have to get the p to the other side, so I multiply everything by here. 1 over p. So I get 1 over p dP equals K dt. You can see at this point, and I'll underline them in orange, I have separated the p's and dp's to one side, and I have separated the t's, which are none of it here, usually there aren't, and dt's to the other side of the problem. Now that I've done my first step, which is separate, I'm going to end up integrating both sides of the equation. Let's do that with red. So if I were to integrate both sides, so this is what we're going to remember and have written down anyway. The integral of 1 over p is the ln of the absolute value of p equals the integral of k is k, what is this, based on t plus c1. I only have to put a c on one side of the problem. So on this next one up here, let's integrate the integral of p. I'm going to come down to make it even. The integral of p is 1/2 p squared equals kt plus c1. And if I do the third type, this is 1/3 p to the third equals kt plus c1, where c is some constant that's added on. The only one that's ever kind of tricky is the one that involves 1 over p. You got to remember to do the ln function on there. So I have now done the second step on all of these. which is integrating. And then we are going to solve. And solve is just getting P by itself. So we've done many times the step for this problem right here. We know what we're going to end up with. I'm just going to work this one out just in case for right now. So I got to get rid of the ln of P. The opposite of lning is eing something. Absolute value of P equals E to the KT plus C1. Absolute value of P equals E to the KT times E to the C1. Absolute value of P. And this one is the only special one that's kind of like this. C2 EKT. P equals plus or minus C2 EKT because of the absolute value sign. And because it's plus or minus, it just becomes some other problem like that. If we start out inversely proportional, don't even worry about these steps. You're never going to do them. You're going to write to P equals CE to the KT. On the other ones, you got to kind of solve them out. You're just doing the opposite of things going on. So to this one, I'm going to multiply 2 on both sides to begin with. P squared equals 2 KT plus C1. I'm going to leave it like that. To get P by itself, I'm going to square root both sides. P equals the square root of 2 KT plus C1. And I will leave it like that. That's P solved by itself. Let's do the other problem over here. I think I can do this in one step. This is going to be P. Now let's do it all the way up. Multiply it by 3. P cubed equals 3 KT plus C1. And P equals 3 KT plus C1. All of that to the 1/3 power. The steps for all the other ones other than the first one are usually pretty straightforward and easy to do. And we've now solved that differential. Very often they will give us, so that's 3. Step 3 is solve. So I've solved it here, here, and here. And then when they give us problems like this on the AP and other things, they usually give us an initial condition and conditions to find out other values. On the pocket problem, it's pretty straightforward. If they tell us that at t equals 0, the population is 500. If I fill it out into that problem, 500 equals CE K to K0. 500 equals C times 1. C equals 500. So I'd fill that number into the equation. So C is 500. KT. That's usually how they work that problem out. On the other ones, they might do the same thing. They might give me a constant or a variable, and we'll have to solve. We'll just take that number and put it in and get their answer out. It's a little harder on these, but we can use the calculator to do it. But we're going to look at those in a couple of problems that are coming up. The only other type of differential equation to see, it's actually in your packet, and if you have it on the test, literally just refer to your packet. It's on page 31, and it's a difference problem. I'm going to flip this page off here. And difference equations are when there's a difference, temperature changes as time goes by. So as a quick example, I have an oven. And the oven is at 350 degrees. That temperature is not changing. That's a constant temperature. And I have cookies. A potato I'm going to put in the oven. And the potato is at 70 degrees. That potato's temperature is going to change as time goes by. So I'm going to put a little T on here. Temperature changes as time goes by. And if I told you that the rate of change of the temperature of the potato, let's call this P. Let's call it P. Okay. The rate of change of the potato as time goes by is directly proportional to the difference between putting the potato in and the temperature of the oven. So this is very straightforward in order where to put numbers in. Which number is always changing? 70 is not going to stay the same. The potato is going to change temperature. We're going to use the letter P for that. The difference between the two is going to be 350 minus P. That's the rate of change for those right there. Sometimes the problem is not a oven, but it is a... It actually won't matter which one is bigger or which one is smaller. The question will end up working out itself. And these problems always work out the same way. The answer to this one is always going to be P equals CE to the KT plus either negative 350 or positive 350. Well, the question is, how are we going to know? The best part is we have our calculator to help us solve this. Okay, built into our calculator is a differential equation solver. It's pretty straightforward. We use it every time on the test. And if we go down to calculus, all the way at the bottom is differential equation solver. The only thing I have to remember is I can't put in dp over dt. I have to put it in with its basic symbol, which is p prime. P prime is under the pi symbol. P prime equals k. Got to use the times key. Close parentheses. 350 minus p, and the parentheses, comma, my independent variable, which is time, and my dependent variable, which is p, and just hit enter. And there is the solution to the problem right there, which is p equals some constant, e to the, it says negative kt, it won't make a difference one way or the other whether you do k or negative k, plus 350. So I could have done here, plus 350. Now I can put a negative on there if I want. The reason the negative doesn't matter is when you work out the problem, it'll give you the correct number that goes up there. And let's say they gave us a condition here. Let's go with, T0. K equal, population equals 100. I already know what C is going to be, but I'm going to work that out for you just to show you. Population equals C, e to the negative k, 0, plus 350, where p is 100. So I'm solving for C. 100 equals C times 1, plus 350. Subtract 350. And we get negative 250. So the C is negative 250. It's always going to be the difference between whatever you started out with, the temperature-wise. Oh, I did that wrong. I said 100. We know what the temperature was at time 0. Time 0 at 70. Let's fix that. 70 minus 350 is negative 280. Sorry about that. So in the end, the potato temperature is equal to negative 280 e to the kt plus 350. And this number here will always be the difference between what you started out with and what you have in the end. Okay, so that's a quick overview of differential equation problems. I'm going to show you one more general type. Shouldn't take me that long. And they're in the packet if you need to see more on page 34. I think on the test they're going to show you ones kind of like this, where you're going to see dy dx equals negative 2x over y. So in order to solve that, we're going to separate by cross multiplying. Negative 2x dx equals y dy. I've separated. Now I'm going to integrate. Negative 2x to the second over 2 equals 1/2 y squared plus c. And then I would have to solve for either x or y. Most likely I'm going to solve for y to get y by itself. So I'm going to subtract the c. Half y squared. Multiply both sides by 2. And I get negative 2x squared over 2 minus c equals y squared. And then we get y by itself by square rooting both sides. C equals y. So that one is that solution solved. It doesn't matter where you put the c or move it around or switch minus signs. If you have to work out a constant, it will always end up working itself out at the end. And negative and positive signs always cancel each other out as you're going there. Okay, this was video 1. The second video is coming next. It's an actual differential equation problem from the AP test. I will send that out, and you can work on that on Tuesday.